Okay, we are ready to start going through your gizmo here and look at acceleration. I'm going to ask the sub to stop here for a couple minutes. All of you need to again get this document downloaded and opened out of your Canvas module, and then you will need to get into your explorelearning.com and open up the gizmo that says Sled Wars Acceleration. Okay, let's begin. As usual, we're going to do some prior knowledge here before we start working with the gizmo. Then we'll do the warm-up where we see down here. Once I've shown you how the gizmo works, you're actually going to be working through part A. I will talk a little bit about it, and you can see here this is a very short gizmo for you, so it should not take very long. Okay, so as we go here, it says a car rolls down a hill. Where would his speed be lowest and greatest? Okay, so again, we're just going to answer this. Now, as normally, if I were in class, I'd be asking you to give me these answers. Since I'm not, we'll just go through this. But as a car rolls down, where would you expect it to be its lowest? Talking about its speed, obviously, it's going to be slowest at the top of the hill and greatest at the bottom of the hill, because gravity is going to make it speed up. I should say gravity and momentum as it rolls down. And I'm sure all of you already understood that. We had a similar question about that on your worksheet with the roller coaster, and I think we had another one with a skateboarder. So you're always going to be fastest at the bottom of the hill. You're always going to increase speed. The force here that's acting on that is gravity. So what do we call that when an object changes its speed? And again, it can change its speed by speeding up, slowing down, or changing direction. That is what we've been talking about here the last couple of days. That is acceleration. Okay, so get those typed in. Okay, and now we will move on to the warm-up. Okay, it says here, this shows Yeti named Bert riding a sled down a steep hill. Bert plays a game where he tries to wreck as many snowmen as he can. You're going to use the slider that sets the momentum to 5. You're going to check the height of the sled at 25. You're just simply going to click play, and then you're just going to give the number of snowmen destroyed. This time you're going to do something a little different. You're going to have the red sled mass 200 kilograms, how many snowmen destroyed this time, and finally drag the sled to the top of the hill and start at 50. Click play. How many students know? Why do you think this is so? Okay, so I'm going to pull up my gizmo. You can see here is Bird on his red sleigh. I think the first thing it said to do is change your number of snowmen to 5. Okay, I'm going to hop back over to my instructions here real quick. I'm going to check the height is at 25 meters. He is at 25 meters. Right here is your height. Okay, we're going to go ahead and go with 100 kilograms of mass right now. I don't think it told us to change that in any way. So, very simply, just let Bert go. And he is going to hit the snowman. Okay, and actually if you look down in the collision result part, you will get the number of snowmen destroyed. In my case, it is 1.23. So just hop back over here and simply type in 1.23 snowmen. Okay, now you're going to reset. All you're going to do here is change the mass of the sled. You're going to double the mass. Okay, and again, you're going to see how many snowmen you can destroy. So reset. You're going to increase the mass here up to 200 kilograms. That is maximum. Again, we look. This time we get 2.45. So again, I go back here. 2.45 snowmen destroyed, which does make sense here. If we've doubled the mass from 100 to 200 kilograms, we were able to destroy twice as many snowmen. 1.23 times 2 is 2.46, but very close with 2.45. Okay, so we can see that mass here has an effect on the number of snowmen. Now, why is that? Again, that's due to gravity. Now, something I didn't mention, and I'm going to go back here, is the meters per second part right here. Okay, so I'm just going to do a quick review, and I'm going to change this back down to 100 this time. Okay, I want you to pay attention to the speed as I play this. Okay, there's your speed, a little over 20. Maximum sled speed, 22.4. Now, if I reset that, and I move this to 200, okay, and I play, you'll notice the speed there was roughly the same. It had the same speed. Okay, so the mass didn't affect that. Okay, changing the mass did not affect that. Now, we're going to go back. We're going to reset him to 100 kilograms as per your instructions. But this time, we're going to go up to 50 meters, click play, and see how many snowmen get destroyed here. So again, you can just grab Bert, and you can take him to the top of the hill. Okay, we're going to hit play. And let him come down. You'll notice that with the greater heights, we increased our speed. That's one of the things we talked about. The higher you go up, the more time you have to increase your speed. So we're going faster. And this time, we destroyed 2.45. Okay. So we go back. Again, 2.45. Snowmen. Okay, why do you think this is so? Bert was moving faster at the bottom. Now, the whole point of this part was more to just let you see how you can change the gizmo, but you can see here mass affects how many snowmen you dang. Also speed affects how many snowmen you can destroy. But again, that was just to teach you how to use all these different things as we get into this. So we will reset. Let's go back to our worksheet here. We're going to scroll down here to activity set. You're going to check that one sled is selected. That is what you already have. You're going to make sure his mass, Bert's mass, and the sled is 100. You're going to set the number of snowmen to 0, and you're going to check the sled to 100. So we're going to do all those things. He's at 50, 1 snowman. You're going to move this down to 0. We're not worried about that. Okay, so again, 50, 100 kilograms, 0 snowmen. That is the first thing that you need to do. Now, we're just going to look at acceleration and speed in this part. So in the first part here, you're simply with the sled at 50, you're going to click observe the red sled speedometer. So again, I pointed this out to you down here. Here's the speedometer. You can get the actual speed in the down here in the results, but pay attention here to the speedometer as Bert is going downhill. Okay, what happens to the sled speed as it moves down the slope? It's going to either decrease, increase, or stay the same. That's going to be your 3 choices. It says acceleration has changed the speed and direction over time. There are 2 ways that the sled is accelerating as it descends or goes down the hill. Please just try to figure out those two ways and list them. This time, focus on the speed of the sled after it reaches the bottom sill. Click play. What do you notice as it reaches the bottom of the sled? Okay, so what happens when it gets to the bottom? Pay attention again to the speedometer once it hits the bottom. Does it accelerate after reaching the bottom? Explain your answer. So simply yes or no and explain what you think happened. Okay. For part 2 here, again, you're going to look speedometer. What's the speed of the sled? This time, however, you are going to decrease the mass to 10 kilograms. Okay. And now we're going to do the same thing, and we're going to check the speed at 10 kilograms instead of 100. Then you're going to repeat at 200 kilograms, and you're going to pay attention to the speed. So basically, we're seeing what happens to the speed if we change the mass of the sled. Okay. Change your masses to a couple more times and then simply answer this question. Does the mass of the sled affect the speed? That's basically a yes or no question, but I would ask like an explanation, as more mass causes it to increase, more mass causes it to decrease, or something else. Finally, you'll finish up here with the third part. You're going to use the gizmo to measure sled's final speed when it starts at a height of 10 meters and when it does 40 meters. So again, we're just checking how height affects it. We've already talked about that. So what's its speed at 10 meters? What's its speed at 4 meters? Again, how does increasing start affect the final speed? Does a larger height make it increase? Does a shorter height make it increase? Give a full explanation. So finish this up, get this turned in, and then you will be moving on to the graphing, the acceleration graph.